Good morning, good afternoon, and good evening. Welcome back to Chapter 18. We just talked about what characteristics an organism has to have to be considered an animal. You got to be multicellular. You have to be heterotrophic, which means you can't make your own food. You have to develop from an embryo. You have to move. You have to ingest food. And most animals have tissues and organs. Here we see an example of a heterotroph. This is a giant python eating a deer. Heterotroph. You have to eat other organisms. There are about 35 different phyla of animals. Remember, domain, kingdom, phylum, continent, country, state. There are about 35 different states of animals. There's about 35 different phyla of animals, and we're going to talk about, give or take, about a dozen of them, of the most common ones. Now, there are, like I said, about 1.5 million-ish species of animals. Yes, 1.5 million-ish species of animals. But when I say the word animal, you think this. You think vertebrates. If we were to go around the room and for an hour, and everyone's going to name a different animal, most of what people would name would all be vertebrates. All right? Please try to remember that not all animals are vertebrates. And if there's 1.5 million species of animals, the real question then is, well, how many of them are vertebrates? And there's about 60,000 species of vertebrates. 1.5 million versus 60,000. If you have $1,500, how much is 60? A little, but not a lot. 1.5 million species of animals, 60,000 species of vertebrates. And of those 60,000 species of vertebrates, half of them are fish. Half are fish. 30,000 species of fish. So now we're talking about, when we talk about vertebrates, there's about 30-ish thousand species of vertebrates that live on land. 30,000 versus 1.5 million species of animals. There are just 1 million plus species of bugs, of insects. So now that 1.5 million comes down to 200,000 or 300,000 species of animals that aren't bugs. The 1.5 million species of animals, 2/3 of them are bugs. Most animals are beetles. Let me explain that. If we were to go and write down the name, the species name of every animal on a little slip of paper, 1.5 million names on sheets of paper, strips of paper. So you have 1.5 million strips of paper, each one with the name of a different species on it. We put it in a huge barrel and we mix it all up. And then we pick someone at random to pull out a piece of paper. They pull out one of those slips of paper. What would they probably pull out the name of? It would probably be the name of a beetle, because most animals are beetles. Most animals are bugs. There's more bugs than anything else. Animals have body plans. Animals, if you look at a tree, they have a rough body plan, but you can't really plan where the branches are going to come off. With animals, animals have body plans where you can guess where the bits and pieces are going to be found. The first plan is no plan. The first body plan is asymmetrical. What that means is that there's no way to evenly cut the animal into mirror images, just like a tree. Could you cut a tree and end up with mirror images? And the answer is no, you can't, because they don't have a strict symmetry like that. Plants are asymmetrical animals. Sponges, specifically, are asymmetrical. There's no way to divide the animal into two equal halves. This is a picture of a sponge. If you go into like one of those beauty stores and you buy a natural bath sponge, this is a natural bath sponge. It's an animal. Our next body plan is radial symmetry. Radial symmetry is the symmetry of a pie or a cake or a pizza. how many different ways are there to cut pizza into 2 equal halves? And the answer is, well, there's a lot. There's a lot of ways you could cut a pizza and end up with 2 equal halves. A lot of ways to cut a cake and end up with mirror images. All right, that's radial symmetry. The only animals really that have radial symmetry, for the most part, are jellies. This is a jelly. You'd say jellyfish, but we don't say jellyfish because it's not a fish. So we just say it's a jelly. And if we look at this, how many ways can we cut this thing and end up in equal halves? Well, there's a whole bunch of ways we can cut this thing in equal halves. All right, radial symmetry. There are a couple groups of animals that have radial symmetry. Jellies are probably the most common ones. Our last plan of symmetry is bilateral. What does bi mean? Bi means two, lateral means sides. Bilateral symmetry means that there's only one way to cut that animal in half and end up with equal halves. If we look at this little animal right here, what is the only way to cut that animal and end up in equal halves? You'd have to go straight down the middle, right there, to end up with equal halves. Bilateral symmetry, two sides, a left and a right. You could cut me this way, and you'd end up with two halves, but they would not be equal. You could cut me this way, and you'd end up with two halves, but they would not be equal. The only way to get equal halves, mirror images, is to go straight down the center, and when you do that, you end up with two sides, the left and the right. That little one right there, that is a cute little one. His nose is a little bit orange. This is, at this time, he would only eat sweet potatoes. And if you've had kids, what do you feed kids? You feed kids what they will eat. At this time, he would only eat sweet potatoes. And so he had so much carotene, the orange pigment in sweet potatoes, that it started to build up in his little nose. All right, that's a cute little animal right there. And that is actually my hand. This is from a long time ago. With bilateral symmetry, you end up usually with some amount of cephalization. Cephalization. C-E-P-H, ceph, it means head. So with cephalization, you mean head formation. With bilateral symmetry, you often get cephalization. With cephalization, head formation means there's a concentration of sense organs. Usually there's going to be a brain, and there almost always is a brain. Wherever the brain is, there are sense organs attached to it, like eyes, like ears, like nose, like mouth, chemical detectors, light detectors, vibration detectors, all right, a concentration of sense organs. When you have a head, which has a concentration of sense organs, you usually have a preferred direction of movement. And what way is that preferred direction of movement? Think of a dog, think of a lizard, think of a fish, think of a snake. What goes forward? The head. You go head first wherever you're going. Why would you want to go head first? That sounds dumb. This is the thing that detects everything. It would be nice to know if there's something to fall into. It would be nice to know if there's poison we're about to crawl into. So you put the sense organs there first, so the sense organs know whether there's something bad over there, and so you could back away. That's why you go head first. This group right here, or rather this graphic right here, shows the main groups of animals that we're going to talk about based on how they're related to each other. We have this ancestral colonial protist in the remote past. This is before the Cambrian explosion. This is during the Precambrian era. There was a group of colonial protists, one that split into two groups. One group went on to make what we call modern-day sponges. Another group developed true tissues. These did not develop true tissues. Another group developed true tissues, and then they turned into all of these organisms. One group went on to become what we call the jellies, the cnidarians. That second group then switched from having that radial symmetry to being bilateral symmetry. So that's why they're called bilateralians, because what they have in common is bilateral symmetry. And then they split into these other groups that we're going to talk about when we get there. And each time, there is some pattern, there is some feature, there is some process that these groups share, which is why they're grouped together. For example, the roundworms and the bugs are grouped together in this group called ecdysozoans. Ecdysis It means to shed their skin. Nematodes and bugs both have to shed their skin to grow. They're grouped together because they have a feature that makes them common with one another. And we'll talk about those features as we get there.